Now let's after we bring this spreadsheet into R. Now let's look at some how do we deal what we're going to do with data set. Now let's first look at what variable exists within this data set. We can look at what variable exists within this spreadsheet by using fixed data, as we showed before. You can really see that these are the different columns in this spreadsheet. And first we'll show you the name of variables. Okay. Now we close down this spreadsheet. But also we can use this method. We can use this function names and parentheses. Within the parentheses, you put the name of this of the data set that you call data, and you run this, and that should give you all the variable names that exist within the data set that exists within this spreadsheet. Okay, and that became very convenient because we may want to call individual variables. For example, this is how to extract a particular variable from the Excel data frame. We write the name of this data set. The data set, we call it data. Then we use a dollar sign. After dollar sign, we put in the name of a specific variable. For example, one variable is called population pop 1990. So after dollar sign, we put in pop 1990. So we have to the R is case sensitive. So if the original variable is capitalized, you also need to capitalize. So that's so let's run this line. We have this for this command, we simply will call this particular variable within the data that is called pop 1990. Let's run this line to see what we get here. Okay, we got this. So this is all the values for different 50 states plus Washington D.C. that their 1990 population. Another variable is called median rent. Is here median rent. So we put the data dollar sign at the dollar sign median rent, the met rent. Again, capitalize, and we run this. Let's see what we get here. Okay. So we have 51 numbers. The median rent value for the 50 states and Washington D.C. So this is how we pull out, how we extract individual variable values from Excel data form, Excel spreadsheet. Now, sometimes you also feel that this writing is very cumbersome. You like to give a more succinct name to the variable that you can extract from Excel data frame. So what you do here is that you give it a name. For example, for data dollar sign pop 1990, after you extract it from the Excel spreadsheet, you can call it pop 90. We do this. Okay. So we assign these values to this variable that called pop 90 within R. So this is assignment notation. So we run this. Okay. After that, nothing seems to be happened. But if you highlight pop 90 with the computer cursor and right click, run line or selection, and let it go, you can really see that now the 651 values are the population for 1990 for the 50 states plus Washington D.C. You can do a similar thing. You have a variable within R spreadsheet that is called area. That is the physical area of 50 states plus D.C. And here you call it data dollar sign area. You define that within R, simply area. Now you run this line. Now let's see, highlight this area to see the value. Okay, so these are the 51 values that show the physical area of 50 states plus Washington D.C. Okay. Now after now we have two values. One is population, 1990 population. Also another is area. We can use these two values to calculate the new variables. For example, we can use population and the physical area of states to calculate population density of different states. And therefore, what we can do is this. Okay, we use dollar. We use this variable population for different states and Washington D.C. divided by the area of different states and Washington D.C. to calculate population density. And let's run this line. And then we see what is the value, what are the values of population density for 50 states plus DC. Let's highlight pop then, right click and run line, and what we got here is 51 numbers that shows that the population density of 50 states plus Washington DC. So this line is the same line as this line because this line we directly use the variable that we extract from the spreadsheet. But also this is after we defined the 1990 population and area within R, we can directly use the name of this variable within R to calculate population density. So if we run this line, we should get the exactly same result as we run this line. So now we see this pop then run down, we should get exactly the same 51 numbers that show the population density and population density for 50 states and plus Washington D.C. Now, if you also want to add this newly calculated variable into the spreadsheet and as a new variable, we can do that. Let's give it a new name. Let's simply call it capitalized pop then because all the variables within R, within the data frame in R are capitalized. So let's also, when we put a new variable into that data set, let's also use the capitalized variable name. So let's call this a variable pop then, capitalized. And since we're going to put this variable into the spreadsheet within R, so we say data $, after that is pop then. And this value should be the same as this pop then. Okay, this pop then is what we calculated within R. So we want the variable within dataset should be the same as this variable. Okay, let's run this line. After you run this line and you go to look at your data frame within R, you can take a look at this is all the existing variables within the spreadsheet of our data frame. Now you can see the last column. The last column is a new variable that we put in. So after you put in this last variable, you can really check for different states what are their population density values. Okay. So now since we altered this data set that we're bringing from Excel, we want to save this new data set. So we use this function write.xlsx. And again, there's a data set that we haven't saved from R is called the data. Then we write down file.choose parentheses, and so that we can put this newly revised data frame from R. We can save that onto our folder on the computer. Let's run this line. After you run this line, it is Windows opened, so you can choose a place to save your data file. Let's call it states new, because within this data set, it contains a new variable population density, and give it extension XLSX, and then you say open and create this file. Yes, Now this new data set is saved on your computer. Okay. Again, since we said that for Macintosh, the file choose this particular function does not work. So for this part, you need to write a specific detailed path that lead to the folder where you want to save this new data. Okay. Now, finally, let's look at how we can run descriptive statistics. Remember early on, we created a data set called my data. Here, let's come back to this place, my data. My data is here, my data. My data, if we run my data, fix my data, remember we have 5 values within my data. This value form is a variable called var. Now let's see how we run basic descriptive statistics for the variable we called var. Okay. Now let's come back to the section of the lab sheet that deal with that issue. Now within this data set, my data, we know that there's a variable called var. So now let's let's call this. Let's first run this part. So my data $sign and var. Let's see what is the what this variable looks like. See the 5 value, the 5 value. Now let's rename this 5 value into a more succinct variable name. Let's call it V. Okay, let's run this. Okay, let's call it V. Now if you look at what's in the V, these are the 5 values, 3, 5, 6, 1, 9. Now we know that this variable V contains 5 values. So if you want to find the mean of this variable, if you want to find the mean of 3, 4, 6, 1, 9, you can simply run that mean parentheses this variable V. That gives you this 4.6. If you want to find the variance of the variable V, you can run this. That gives you 9.3 variance. You will find the standard deviation of this variable, you run this. Okay, if you want to find the coefficient of variation, we know the coefficient of variation is defined as the ratio between standard deviation and the mean. So this is how we find the standard deviation of the variable V, and this is how we find the mean of variable V. So we simply find out the ratio between these 2 values. That should give us coefficient of variation. After you run that number, you can run CV and see what is the actual value of coefficient of variation, and that's 0.66. Okay. Then what is the median? What is the, can I change this value? We should have variable V. Okay. Variable V, not variable A. Okay. Now let's see a variable. What is the median of variable V? This is 4. And what is the quartile? What is the quartile of variable V? Okay. Quartile is that we define the variable into 4 equal sections. Each section they have an equal number of cases. Okay. So that's what happened. You see, the minimum number in the data set is 1, and 3 divided number into 3 is called the first quartile within the from between the smallest number and the first quartile. You have 25% of cases, and 4 is the second quartile, which is also the median, which divides data set into 2 equal halves. On each half, we have equal number of cases, and this is the third quartile is 75th% is percentile, which in the below it you have 75% of all the values, and between the third quartile and the large number, you have 25% cases. So within each of this interval, you have 25% of cases. If you want to find, we also study the concept of percentile. to find out some percentile, you run this command. Okay, you run this quantile for variable v. If you want to find out the 75th percentile, you run this. Okay. For this variable v, I'm going to find 0.75. This should give you 75th percentile. So the value below which there are 75% of cases in the variable. You run this, you should get 6, exactly same as this, as the result we obtained earlier. Now, if you want to find out what is the 82nd percentile, the value below which there are 82% of value in the variable, they simply run that. Okay. Quantile this variable v and 0.82. That should give us 82nd percentile for the variable, for this variable. Okay, let's run that. It's 6.84. So that's how we obtain a percentile. Now, what is the maximum value of the variable v? Is 9. What is the minimum value of variable v? Is 1. And there's a really quick way to find the solution, to find some general descriptive statistics. We can simply run summary and parentheses and this variable, and let it go. You can see, the minimum value is 1, maximum value is 9, and the median is 4.0, the mean is 4.6, and the third quartile of 75th percentile is 6, and the first quartile or the first quartile is 3. Okay, based on the same principle, you can also, for the entire data set that we bring in R from our Excel spreadsheet, for the entire data set, you can also run summary. Let's see what we're having here. Run summary for the entire data set, and this is what we got. We know that within that Excel spreadsheet, there are many different variables. Here, look at the area. For the variable area, minimum value, maximum value, the first quartile, the median of the area, the mean of the area, and 75th percentile of the area. Same way for population 1990, the minimum value, the maximum value, the median, and the mean, and the first quartile, second quartile. And that is a very quick way to obtain some of the fundamental, basic descriptive statistics. Now, so this is how we do everything within R. You can use very similar procedure to do everything within R Studio. Now, in this case, R Studio provides a convenient process to look at what the functions, what the packages exist within R Studio. Let's go to this little panel, right-hand panel, lower corner. Within this panel, you click this the tab say packages. Now you can see a list of packages that exist within R Studio. For example, we need to use the packages that we call XLSX. Let's see whether it exists within R Studio. Okay, you go through the entire packages. You can really see that that package is somewhere here. So this package exists within R Studio, and so after you click the name of that package, give us some more detailed information about that particular package code. It will tell you what version of that package is, and also what specific functions exist within that package. Okay. So this is one thing that makes R Studio very convenient. Almost like you click a button, you can really find out what packages exist within R Studio. Okay. Now let's. So this is basically the end of this lab. I hope you enjoyed this. I see you next time. Goodbye.